Hi, welcome to BC Video 9.10b Part 2, the end of Special Series. 27 through 40, find the Maclaurin series for the function. Use the table of power series for elementary functions. In other words, use a known series on page 684 and use substitution, multiplication, or division by a constant or monomial, or maybe adding, subtracting two series, or maybe differentiating or integrating to go from one series to the next, okay? So, oh, this is what's in the table. So this is my version of what's in the table and the ones you should know. So 1 over x centered at 1 is this one right here. I prefer 1 over 1 minus x personally. And then you could replace 1 over 1 minus x by, you could replace the x by negative x, okay? ln x centered at 1, we did that in a table, but these are the ones you should just know. This and 1 over 1 minus x, but you should just know these. So e to the x, this is all centered at 0 here, is this expression right here, this power series right here. Sine x is the odd function, cosine x is the even function. Notice e to the x is all positive terms. Notice that both sine and cos are alternating. Both start with a positive. Sine's an odd function, so it starts with x to the 1 over 1 factorial, x to the 3 over 3 factorial. Cosine's even, so it starts with x to the 0, which is 1. Next one's x squared. Next one's x to the 4th. Arctan, the difference between arctan and sine, which look very similar, is that arctan has no factorials on the bottom. It's just over 3, not 3 factorial. It's just over 5, not 5 factorial, etc. Okay, so they do look very similar, so do pay attention to that. Okay, so they want a Maclaurin series near 0 for e to the 3x, so we're going to start with our known e to the x, and we're going to replace our x by negative 3x. So we replace all the x's by negative 3x. We replace this x by negative 3x. Remember, they'll always rewrite this as negative 1 to the n, 3x to the n. Number 38, e to the x plus e to the negative x. Don't worry about this. You won't learn that until university. So we start with e to the x, which we know. We know e to the negative x. We just replace all the x's by negative x's. So that would look like this, right? And then what we're going to do is we're simply going to add these series. These are polynomials, and we're simply going to add the like terms. So 1 plus 1 is 2. X plus negative x is gone. X squared over 2 factorial plus x squared over 2 factorial is 2 times x squared over 2 factorial, etc. All the odd ones will be gone, and you'll have 2 times the even ones. And therefore, it's simply going to be, now, you can get this one by observation. Don't try and add these two together. That's a little too complicated. At this point, look at this and go, oh, look, x to the 0, x to the 2, x to the 4. So it's x to an even. There's a 2 in front of each one. Pull that on the outside. 0 factorial, 2 factorial, 4 factorial, even factorial. Okay, if you expand this, it's impossible to see the actual pattern. And as I said, you are doing this from here to here. You're doing that by observation. Okay, make that a bit smaller. So that's how you're doing that, by observation. Find a Maclaurin series for each function, so that's near 0. Hint, multiply or divide the known series for sine x or cos x by monomial x. So x times cos x, you're simply going to take our known series for cosine x and simply multiply through by x. You're multiplying by a polynomial, by a monomial, so that's just distributive property. And so that becomes x minus x cubed over 2 factorial. Again, I think the easiest way from here is to go from here to here again by observation. Okay? So once again, we're doing that by observation. That's usually easier than trying to actually take the two series and start dealing with adding two series and how that works. Okay, the worksheet. Let me pause and pull up. Okay, so here's the 9.10 worksheet, which will be posted in my Buckley. This is just from a Larson textbook, a previous, it's not a Larson textbook actually, it's from an old edition of a textbook, not Larson. Okay, so we are looking at number 24. So let's look at number 24. It says, use a power series to compute to the indicated accuracy the value of the quantity and compare the result with your calculator value. So number 24, we're trying to approximate the fifth root of e, which is e to the 1/5. And they want it to 4 decimal places, okay? So we're going to start with e to the x, which we already know what that is. We don't have to create that one. And we simply replace all the x's by 1/5. And I don't know why. Oh, right, this is 1/5 squared, this is 1/5 cubed, etc. All right, and then you would use a calculator, which always makes me laugh, because if you have a calculator to do all this, how come you don't have a calculator to do the fifth root of e, but whatever. Okay, so if you use this approximation, remember you'll round each one of them to 5 decimal places so that you'll end up with 4 decimal places of accuracy at the end. So once you get to this point, then you round it to 4 decimal places. And we'll talk about error later on, but the sixth term would be, if you figured it out, 1 over 5 to the fifth times 5 factorial would be 0.000002, and that's why we don't need to go any further. Now, this is the thing. You would have to figure that out because you don't know where to stop. You stop as soon as you get to the first term that's less than 0.00005, because if it is less than that, it will not affect the first 4 decimal places. That makes sense? Okay, so you'll actually have to just keep on trying them until you get to the first one, which is less than this number, and the first one that's less than that number is when you're at the point of 5 factorial. So you do not use that one.